these are the clean carbon research themes, and this one, oops, is consequences. And consequences are what we're going to talk about now, namely climate change. So, explain to us who you are.
Who am I?
Yes.
That's a very deep and philosophical question, isn't it? So my name is James Dyke. I'm a lecturer in sustainability science at the University of Southampton. I'm a co-chair of something called Sustainability Science at Southampton, and I'm the programme director of the new Masters in Sustainability.
Okay. So, what is your role in tackling climate change?
I talk about it.
Good.
I talk about it, and I think also I've become something of an accidental activist. A number of academics, I think, have undergone something of a journey where we've been researching climate change, environmental change, how humans are changing the environment, how humans are changing elements of the Earth system, and then we come to the conclusion it's not really very good, is it? We're a bit worried, a bit concerned. And so there's been a bit of an erosion of the firewall between what we consider to be the science and then the policy or the wider implications of that research. Previously, we would like to have kept a nice strong separation between what academic output, what the science says, and then maybe what we should do with that science. I think more recently I've been increasingly concerned that the science isn't sufficient. You can't just simply say these are the impacts we're having on the Earth system. We've got to tell more people about it, and we've got to be a little bit more engaged in trying to follow through some of the implications of that science. So yes, I research sustainability science, and that means considering the impacts of things such as climate change. But more increasingly, I'm trying to write, let's say, popular articles, popularise the conclusions, some of the findings of this research.
Okay. And what are the key challenges that need to be tackled then in this field of research?
In terms of climate change, there's a very simple way to look at it, which is if we want to keep warming to within 2 degrees Celsius, in fact we should really be looking to keep warming to within 1.5 degrees Celsius, then we need to leave a certain amount of carbon in the ground, or if we don't want to leave that carbon in the ground, we need to work out how to get it out of the atmosphere quite quickly. At current rates of emission, if we want a better than even chance of staying within 1.5 degrees Celsius, then we might blow our available carbon budget within as little as 5 years or something. And there's nothing like the required reductions in emissions happening. Some countries, you hear about success stories such as Costa Rica, which are almost entirely powered by renewables. But for the vast of the industrialised nations, we're still digging up fossilised carbon and still burning it. So the greatest challenge is how do we stop that carbon getting into the air, and then, given that we can't really see how that's going to happen in a matter of 5 years, how are we going to get too much of that, the extra carbon, how are we going to get it out of the atmosphere and put it in the ground, and that's carbon capture and sequestration. So I think one of the biggest and scariest things that the general public, if I may, don't appreciate about climate change is that we currently have no realistic way of reducing emissions in the timescales that we have, nor do we have any realistic way of implementing the carbon capture and storage technologies that we need. If we're going to keep to 1.5 degrees Celsius, we need widespread deployment of carbon capture, sometimes also in conjunction with something called BECCS, bioenergy and carbon capture and storage. And that's the only way we're going to keep to 1.5. Nobody has much of an idea how we're going to do it, and it's absolutely crucial to the maintenance of our industrialised civilization. And if we do get it badly wrong, then yeah, it could be game over.
I said at the beginning that I showed the 6 themes of the Clean Carbon USRG. You're a member of the Clean Carbon USRG in the consequences theme. How important, knowing that these USRG groups are interdisciplinary, do you think that being interdisciplinary or multidisciplinary is to this work?
It's absolutely crucial. So as well as the Clean Carbon USRG, may I mention the Nexus? So we've got Nexus thinking, food, water, energy, and it's been shown time and time again, if you just look at the problem in terms of, okay, let's increase the amount of energy we've got, or let's increase the amount of food that we've got, you can make situations much, much worse. So the classic example in terms of climate change and that kind of nexus environment were biofuels. So we can't burn fossil fuels, so let's grow crops and turn those into biofuels, and then let's burn that instead. And because when the crops grow, they absorb carbon dioxide, when you burn it, then it's going to be carbon neutral. So let's do that instead of digging up, oil and making that to gasoline or diesel. And it proved to be a complete disaster, because what happened, there were government incentives to produce biofuels, which meant that some farmers switched from growing crops to feed humans to grow crops to feed cars, and we were literally taking the food out of people's mouths, and it increased the price of food, it destabilised global food production systems, it increased rates of deforestation in some places, increased rates of deforestation of the rainforest, which is some of the greatest stores of biodiversity, and millions, not billions of tons of carbon dioxide are locked up in those trees already. So that was a classic example when you didn't think through the consequences of implementing a policy which was designed quite narrowly and specifically to address a particular issue, which is how policy gets formulated. So USRG, such as Nexus, such as Clean Carbon, such as the wonderful sustainability science that I happen to be involved in, are meant to get people from different disciplines, engineers, economists, philosophers, historians, people interested in policy, people interested in demography, and get them to explore central organising questions or problems, but from those different angles. Try to get a better appreciation of the multifaceted elements of the challenges. So they're brilliant like that, and we need these kind of USRG activities if we want to make these main important, these kind of step changes in tackling these problems, because as we know, we don't have much time.
Okay, and so finally, who are the key players in your field, and who are the rising stars, if you can think of any?
Well, key players, everyone's going to mention their favourite climate scientist, so I'm not. A rising star, I'm going to mention somebody from the Potsdam Institute for Climate Impact Research, or PIC, which is a bit of a less of a mouthful. So PIC's become a world leader in trying to understand the science of climate change, but then also what drives that, which is important human agency, and then what are the consequences, what are some of the impacts, what are the things we need to be mindful of. And there they have a young scientist, Ricarda Winkelmann. Ricarda has already got the kind of CV that I think a professor would be very proud of. She has some incredibly high impact papers. She's being published in journals such as Nature, and she works with people such as Johann Schnellhuber, who was the founder of PIC. What I find particularly exciting about her research and some of the other research that happens in that organisation is they really do profound interdisciplinary or transdisciplinary science. So they look at it from a physical modelling perspective, but then they try and include those social factors. So one way to look at the climate change problem is that you've got humans, or you've got a social element, and they're interacting with the planetary system, this kind of ecological element. And how do you build models that truly represent those important social ecological interactions? It's easy to say, but it's incredibly hard to do. And I think what Ricarda has demonstrated is that you can do that. So her background was from an empirical scientist. She did proper science, go to Antarctica, measure glaciers and things like this. But you can take that kind of hard natural sciences approach and you can join it up with social sciences, where scientists or academics from other disciplines, and make really important contributions. And she is still quite young, and I'm sure she has an incredibly bright future ahead of her.
Thank you very much, Dr. James Dyke.
It was a pleasure.